Thank you everyone for being here. And we would love to get started with some introductions. Thank you for introducing yourselves in the chat. And Emily and I are actually going to introduce ourselves next.
All right. Thank you, Julia. So my name is Emily Miller. My pronouns are she, her. I was a high school chemistry teacher for 10 years. And when I was a teacher, I had the opportunity to teach in our alternative learning program. I taught regular chem, I taught honors chem. So I had a lot of opportunities to teach a lot of different kids with a lot of different strategies. I considered myself an NGSS pioneer and advocate in my science department. I was also a PLC lead, so I had the opportunity to lead a lot of data chats and data-driven dialogue. I like data. And now I have the pleasure of working with InnerOrbit and helping districts implement InnerOrbit within their schools, which has been super awesome. And this doesn't mean I'm like a sweet hater, but like I would like rather eat a steak than chocolate like any day. Like when I go to a restaurant, I will order an appetizer before I order dessert every single time.
Well, I'm glad Tracy is with you because I am not. I would rather not eat as much just to have dessert. And my name is Julia Mota. I was a teacher and tutor for elementary students in the Dominican Republic, and I've been supporting teachers and districts with their NGSS implementation for the past 3 years. I'm the InnerOrbit's district engagement manager, and I work mostly with folks in our East Coast. So I have the pleasure to partner and provide guidance to schools and districts implementing assessment in their NGSS instruction. I also think matcha is better than coffee just because coffee gives me the jitters. So, and matcha is delicious. I know some people say it tastes like grass, but I disagree with that. And today we are going to talk about preparing for the Connecticut NGSS science assessment. So, Emily, do you want to walk us through our agenda for today?
Yes, I'd be happy to. So today our objective is we're going to go ahead and analyze some released test items from Connecticut. And then we're going to dive into resources and strategies to help practice and prepare for the Connecticut NGSS science test. We're going to be here for about 30 minutes. The first thing we're going to do is we're actually going to look at a released test item and we're going to do a little bit of analysis. So looking at the performance expectation and how it's three-dimensional. Then we're going to go ahead and practice some sense making. And so see how we can help our students do that by using phenomena throughout a unit. And we're going to talk about how we can actually help our students by scaffolding back a grade level. And then from there, that'll lead us into how we can actually scaffold up to 3D questions. So we're going to look at some InnerOrbit items while we are doing that. And we would love it while we're doing this, if you have any questions, to please put them in the chat. So you don't have to wait till the end. If something is popping up while we're chatting, please go ahead and let us know. And with that being said, let's go ahead and I want to tell you a little bit just about what InnerOrbit is and what we do. So you've got a little bit of context in case you don't know. So InnerOrbit is essentially 4 main things. The first one is phenomena. So all of our assessment items are clustered around novel phenomena, and we have over 1,000 novel phenomena on our site. So students can be engaged and actually make sense of something new. The other thing that InnerOrbit is we are assessment items. So like I said, we have these assessment items tied to phenomena, and we have over 10,000 different assessment items, grades 3 through 12. And what we do with these assessment items is we like to slowly scaffold them to those 3D questions. And we're going to show you kind of an example of that today. The third thing that we are is data. Like I said, I like our data. So with our data, you can figure out how students are doing on our assessment items. And more specifically, you can figure out how they're doing on the different dimensions within the assessment items. So for example, if an assessment item is looking at the SCP of developing and using models, you can see how students are doing on that particular SCP. And then look at the actual individual elements of that SCP so you can figure out how to best support them. And then the last thing that InnerOrbit is professional learning. So we use research and context-based models and learning. We love physically meeting with teachers and leading professional development, either in person or virtually. And we are constantly modifying and assessing what we have based on teacher feedback. So that is a little bit about us and who we are. So now that we know what InnerOrbit is, let's just talk about what sense making is here really quick. It's probably a terminology that you've potentially heard before. And we're going to look at sense making while actually looking at a released 8th grade science item from the Connecticut NGSS assessment. So if you look here, we've got some flies with some different eyes. Oh, that's cute, that rhymed. And we're looking at the different phenotypes of these flies and their genotypes as well. And so we have a variety of different statements. So the fly's eye structures become wider. The fly's eye structures become narrower. And students need to take these statements and place them in that above flow with those arrows. So organize the statements that complete the chain of events, explaining how the bar mutation reduces a fly's eyesight. So this is a released 8th grade science item, like I mentioned, and what I would love all of you to do is if you could please in the chat answer the question, are students applying their understanding of DNA and proteins to make sense of this phenomena? So just a simple yes or no. So are students using their understanding? I would say yes. And so this kind of highlights that difference between sense making versus representation. So representation questions are essentially recall questions. So it's students communicating ideas that they've previously learned before. So maybe talking about how, DNA like has the code for like what we look like and how our bodies function. Like that's just me recalling something that I've learned before. And representation questions are really good for diagnostic and formative assessments because it lets you as an educator know if your students actually know what they need to know before you teach them new material on top of it. But the problem with it is it's insufficient evidence of proficiency. And what we mean by that is the goal of the NGSS is for students to participate in sense making. So sense making is this idea of having students explaining why or how something happens. So it's taking what they've previously learned and actually applying it to a novel phenomena or a new situation. So like the flies, for example, maybe students haven't talked about fly eyes before, but they're applying what they've learned about DNA and proteins to this new situation. They're making sense of it using their knowledge. Sense making is awesome for a summative assessment because this is a way for you to actually see if students have mastered what the NGSS is trying to get them to do, which is this sense-making practice. So just as a quick reminder about how the NGSS is structured. So when item writers are looking at writing these Connecticut state items, they're going to be looking at these performance expectations or these standards from the NGSS. So this standard, and this is actually the standard that was used to write that fly question that we saw, is MS Ellis 3.1. So it's a middle school level question, LS Life Science 3.1. And each one of these performance expectations has 3 dimensions to it. So it's got the science and engineering practice, the disciplinary core idea, and the cross-cutting concepts. The disciplinary core idea is essentially what students know. So it's them like knowing the content, knowing what DNA is, knowing how that affects traits. The science and engineering practices or SEPs are what students do. So in this case, in that fly question, they were looking at the models of the fly eyes. So being able to analyze and interpret models and use that within what they know. And then the last part is the cross-cutting concepts or the CCCs. And this is how students think. These cross-cutting concepts are broad science topics that students are going to experience at all levels, K through 12, in all disciplines. So it's kind of that through thread of how we can connect everything that we're learning within all of our science classes, regardless of the age or the content area that we are in. So when we're looking back at this performance expectation, MS Ellis 3.1, and again, we're looking at that question down there about organizing the statements that complete the chain of events, explaining how the bar-eyed mutation reduces a fly's eyesight. All 3 of these dimensions are coming into play into this question. So students need to be able to look at those models and being able to analyze and interpret what's going on within the model. They need to understand how traits come from our genes and from our DNA, and they need to know the structure and function of these microscopic structures like your DNA and how that comes into play with the fly eyes. All right. So now that we've kind of re-identified sense making, we've re-identified the NGSS and how those two things are connected, Julia is going to talk to us a little bit more about how we can use phenomena to help students get ready for their state tests.
Thank you so much, Emily. And now that we know what the 3 dimensions are and how they come together in questions, we're going to review some strategies we could use for test prep across the school year so that our students can get used to transferring that knowledge from what they learn in class to these novel scenarios and these novel phenomena. So let's go back to our standard, MS-LS31. And just to recap, it is asking students to develop and use a model to describe why structural changes to genes and mutations located on chromosomes may affect proteins and may result in harmful, beneficial, or neutral effects to the structure and function of the organism. So we've mentioned using phenomena in assessment, but how can we give students opportunities to make sense of phenomena throughout an entire unit? And what are these types of experiences that we can give them to practice for those rigorous questions? Let's look at how we would use phenomena throughout this specific unit. So let's look at a roadmap of phenomena on the InnerOrbit website that we could use throughout this unit. And in the very beginning, we could start with this phenomena about discussing why is this hedgehog white? So since we're still in the beginning of the unit, maybe we would consider a lower stake discussion like a whole class walkthrough. And this is all about how albinism is a genetic condition caused by mutations that affect the production of melanin, which is the pigment responsible for skin, hair, and eye color. And we would include discussion questions that target the cross-cutting concept and the SCP for the whole class to answer together. Moving on to the middle of the unit, we could talk about the reason why Tibetans can breathe so easily at high altitudes. Here we could consider maybe separating the class in groups to answer questions collaboratively in a printed and scaffolded group phenomena exploration. So students would discuss that certain populations living at high altitudes, like those in the Tibetan Plateau, have developed genetic adaptations that help them cope with lower oxygen levels. And in this stage, students are answering rigorous questions that target the GCI cross-cutting concept and SCPs, but with scaffolding from their teacher and support from their group. Now, lastly, we could assess students by building a short online assessment to be administered individually at this point of the unit, maybe towards the end, covering the reason why some people are able to roll their tongue while others can't. So in this case, students would grapple individually with the fact that the ability to roll the tongue is associated with genetic variation in a specific gene, and that this trait is neutral and has no clear impact on an individual's fitness. Doesn't matter how many times you try, you may not be able to do this. So in this final part of the unit, students should be ready to engage with rigorous sense-making question. And teachers can still provide scaffolding if needed, but removing those scaffolds is really important for building student independence and confidence for these state tests. Something I want to highlight is that all of this phenomena is available on the InnerOrbit website, and you can find even more. Per PE, we have from 4 to 6 different phenomena for you to use throughout a unit, but maybe let's say our students are not there yet. And we want to start at a level where they need even more phenomena and even lower grade level phenomena in order to access these rigorous things. Well, there's something we can do for them. And it is, instead of just diving into the MS-LS3 performance expectation that we just saw in the beginning, we could actually go back to elementary school with a 3rd grade performance expectation. So in this case, we're going back a whole grade level band, and at this point, students need to analyze and interpret data to provide evidence that plants and animals have traits inherited from their parents, and the variation of these traits exists in a group of similar organisms. So this is from 3rd grade, and we would just be going back to the previous performance expectation that would be tied to this middle school standard. And in this case, we would just do the same thing and include different phenomena. We could first discuss how tigers get their stripes, and this is all about how many characteristics of organisms are inherited from their parents and how different organisms vary in how they look and function because they have different inherited information. And then maybe we could go over the reason why the same type of flower, in this case, these tulips, look so different. And it's all about the fact that tulips can be crossed to create a mix of flowers with some similar and some different traits. And again, all of this phenomena is available on the InnerOrbit website, and you can find even more per performance expectation. So again, we have from 4 to 6 different phenomena approximately per PE. So you could go into InnerOrbit just to provide your students with plenty of opportunities to practice that transferring into novel scenarios. Now, just to recap how we would use phenomena throughout a unit for test prep, the main takeaway I want to highlight is that practice makes perfect. So phenomena should be used throughout a unit, throughout all units, not only during test prep season. And using different phenomena always provides more opportunities for students to model and practice transferring knowledge and sense making. And let's say if students are struggling with phenomena targeting their grade level band, we can always lower the stakes with a prior grade level phenomenon to give further sense-making opportunities and identify possible gaps in knowledge or skills. And that really sums up the using phenomena throughout a unit idea from our webinar. Now, moving on to how we can scaffold from representation to sense-making, let's actually revisit the whole sense-making three-dimensional idea. And at the end of the day, our goal is to get students to this rigorous performance where they can use their knowledge through the lens of the cross-cutting concept and the science and engineering practice to explain how or why a phenomenon happens. And that's what true mastery looks like. And it is what students need to be prepared for this assessment. But we can expect them to get there overnight. And that's where scaffolding comes in. So how can we support them building up to this level? First, we need to identify the invisible steps we're asking students to take. So if we're expecting them from simple recall to applying knowledge across dimensions, we have to be intentional about breaking that journey into manageable steps. And second, we need to gather data at each step, not just at the end, because we want to understand where students are struggling and adjust their support accordingly. And by focusing on these steps, we are not just preparing students for an assessment, but we're helping them develop critical thinking and reasoning skills that would serve them beyond the classroom. And that's the power, really, of scaffolding towards 3 dimensions. And again, how do we bridge this gap between DCI-only questions and 3D questions? Let's look at it with an example. And we've been talking about MSLS 1.3. So MSLS 3.1, I'm sorry. So let's dive into this phenomenon. Why should we be careful around X-rays? And this is all about how X-rays expose us to radiation, which in high doses can cause mutations, changes in our DNA. So sometimes these mutations have no effect, but in other cases, they can lead to serious consequences like cancer or inherited genetic changes. So on the slide, we see a few ideas. How radiation can cause DNA strand breaks leading to mutations. Second, how some mutations affect only the individuals and others can be passed on. And an example on how radiation can break and rearrange chromosomes leading to genetic changes. So all these things are the ones that we see on this phenomenon. Now, this is the summative 3-dimensional question that we want our students to answer, right? So this one requires students to engage in sense making by pulling together multiple scientific concepts and skills. We're breaking it down so they have to apply what they learned about inheritance of traits and variation of traits while they develop and use a model through the lens of structure and function. And this level of complexity is exactly what we see on the Connecticut NGSS aligned test, but how do we get there? So to bridge that gap, we can expect students to jump straight from representation to sense making, and that's where 2-dimensional questions come in. So they act as a bridge between simple recall and full sense making. So some 2-dimensional questions can actually combine the DCIs and the cross-cutting concepts by asking students to explain how or why scientific knowledge applies through a specific lens. And other types of questions can combine the DCIs and the SEPs, shifting students from recall to application by having them engage in scientific practices instead of just memorizing facts. And by incorporating more of these questions, these two-dimensional questions in our instruction, we're helping students build the skills they need to fully engage in sense making. And it's a stepping stone, the one that we were just talking about, that makes the shifts to mastery feel more achievable and make students feel less frustrated when they're like, oh, but we never talked about flies in class. We never talked about x-rays. So let's take a look at the examples of how these questions might look like. So the first type of question that I'm going to show you is a core content question. And this is a great example that plays a crucial role in assessing whether students are ready to start making sense of something novel. So at this point, we just want to measure student readiness. And before they can actually apply these three dimensions, they need to have a solid grasp on the foundational science ideas of this lesson. And in this case, this question is checking that by focusing purely on the DCI, students can actually answer these questions. So again, do you understand that mutations change the proteins our body produces, which is a key concept in genetics? And then this question is acting mainly as a checkpoint. So if students can answer correctly this type of question, they have the necessary foundation to start applying their knowledge in more complex sense-making tasks. Now, moving on to this second type of question, we combine the DCI and the cross-cutting concept, leaving intentionally the SCP out of the question. And this type of question, again, is the one that bridges the gap between simple recall and full three-dimensional sense-making, because it ensures that students can first recognize how DNA mutations affect protein production and traits, which is the DCI, and then use structure and function as a lens to explain why altering DNA leads to new proteins and potentially different traits. So here we're isolating the DCI and the cross-cutting concept just to understand if students can do those two things together before moving on. And for our next type of question, now we're deliberately combining the DCI and the science and engineering practice while leaving the cross-cutting concept. So we're doing the same thing, but now with the SCP. And this one's important because it goes a little bit further and it allows us to specifically assess how well students can apply their content knowledge through this science and engineering practice, which is developing and using models. And it helps us pinpoint whether students' difficulties come from struggles from applying this specific SCP. So again, what we're doing with isolating the types of questions, the DCI and SCP and the DCI with the cross-cutting concept, is for us to understand a little bit better where the gaps are and adjust instruction accordingly. So if they were able to meet the performance for other questions but struggle with this one, then what they might need support in could be developing and using models. Because they were able to answer DCI-only questions, they were able to answer questions that involved the cross-cutting concept. It was just when the model was thrown in that they started struggling. So by designing assessments this way, we can not only strategically scaffold students' thinking, but we can also gather useful data that will let us make informed instructional adjustments and decisions. And then finally, looping it back to our three-dimensional question, this question is a true sense-making task because it requires students to engage with all three dimensions. And this is the kind of question that best prepares students from the Connecticut state test and for any other state test, and for them to meet actually the performance expectation. So instead of just identifying facts, in this case, they have to recognize how DNA mutations affect protein production and traits. They need to identify which of the classmates' models correctly depicts how mutations affect organisms on a molecular level, and they're still using structure and functions as a lens to explain it. So by scaffolding students, as we did through representation, two-dimensional thinking, and finally three-dimensional sense-making, we ensure that they're truly developing the skills they need, not just for assessment, but for real scientific problem solving. And this is where we want students to be. We want them to be able to answer these questions without any scaffolding, without any teacher help. And by breaking down the journey into intentional steps, we can support every learner in getting to this level of thinking. Now, just to recap, the types of questions that we just asked, we would start with core content questions. Then we would throw in questions that assess the cross-cutting concepts and the science and engineering practices separately. And then we will build up to these three-dimensional questions that at the end of the day, our end goal is to have students independently answer these questions with no scaffolding and with no help. They need to make those connections themselves without us telling them, think about genetic traits. When they see those flies, they have to be like, oh, this is what this is about. So we want students to get there independently. And that's what we do with the scaffolding, just so that they can practice making those connections. And I also wanted to show you some sample data. This is a data set from a district that's given assessments across a school year. And this is showing one of our reports on InnerOrbit, the dimensions report. Some of you may be familiar with it because I realize I'm familiar with some names that are here in our webinar today. So this is all about the data that you can gather to help make informed instructional decisions to support students after giving assessments on InnerOrbit. And this is super helpful if you're wanting to have intentional professional learning conversations, PLCs, in your PLCs, and also just to adjust instruction as a teacher. If you identify patterns in your data, just to make those adjustments and share those successful strategies with your colleagues in case it's helpful. And now I know we've been here for 29 minutes and we said we were going to be here for 30. Ooh, 30 now. So I'm going to kick it back to Emily so she can wrap us up for our last recap of what we've done.
Thank you so much, Julia, and awesome job going through all of that information. We did it, guys. Woo! So hopefully you feel like that you've got a few more strategies to help you practice and prepare students to get them ready for the Connecticut NGSS science test. We looked at a release test item and talked about how the three dimensions play into it, talked about sense making and how we can scaffold students up to sense making with a variety of different types of questions. Starting a free InnerOrbit pilot and actually trying this with your students and with your teachers now is a fabulous time because we're leading right up to that state testing season. So you can actually utilize some of these strategies talked about in the webinar with your students for free with a pilot to see if they work and decide if you want to move forward using InnerOrbit in the long run.